Stephen and I are giving an update on TRICOT done under NACRI. I am going to give an update on the methodology we used. Initially, we did literature review to identify the districts, and then we did a scoping study to identify the agricultural officers and lead farmers, as well as the men and women who participated in TRICOT. We did key informant interviews, FGDs, and short interviews to identify these. We selected 6 districts, and in each district we selected 2 sub-counties and 2 parishes per sub-county. In each of the parishes, we selected 1 farmer group where we identify 10 host farmers, men, women, and youth who hosted TRICOT fields. Eventually, we had 240 TRICOT fields, where we evaluated 8 narrow elite clones, 1 officially released variety, and 3 elite clones from IITA. All the data collection forms were designed in ClimeMob, and all the data was collected electronically using ODK app. We collected data at 1, 3, 6, 9, and 12 months after planting. We trained agricultural officers and lead farmers who collected data. At 12 months after planting, we joined these for data collection. Data was collected and submitted to ClimeMob for management and analysis. We evaluated clones for agronomic traits at 1 month, 3 months, 6 months, and 9 months after planting. At 12 months after planting, we evaluated clones for agronomic traits at harvest, but we also processed the roots into boiled cassava and the flour-based meal products, and we did evaluation of clones for attributes related to these products.
My name is Stephen Angudubo. I'm going to present highlights of the TRICOT evaluation, achievements, and lessons learned. Our data indicated that there was low correlation across all the data collection points, thus pointing to the need for collecting data across all the 5 data collection points. We also noted that there were significant differences between the performance of clones at 12 months, notably at the different collection points, that's at the field, evaluating the boiled cassava meal and also evaluating the flour-based product. We noted that the clone UG120-193 performed the best across all these data collection points. Root yield and stem quality influenced the overall ranking of the clones for overall performance at 12 months after planting. We noted that cooking quality and taste influenced overall ranking of the clones for overall best performance while evaluating the boiled cassava product. And we observed that taste was a major driver of choice of clones for overall performance while evaluating the flour-based meal. Across gender, we noted that root shape, root yield, and disease tolerance influence men's choice of clones at harvest, while all the traits presented at harvest influence women's choice for overall performance of the clones. Steps conducted after TRICOT evaluation, we conducted feedback to farmers to provide the overall performance of the clones they evaluated throughout the process. Later, we bulked the stems of the top performing clones in 6 different districts as a step forward for variety release. We also developed 2 training manuals and conducted trainings on TRICOT data collection for capacity building. Lessons we learned so far, we noted that selection of participants from existing groups improves the overall results of the TRICOT approach. And we also noted that adequate training before the overall evaluation improves data collection and submission of data to the server. We also noted that it is imperative for breeders to develop and adopt phenotyping approaches that capture quality traits to improve variety selection. We noted that TRICOT methodology enhances early adoption of cassava varieties. There is also need to validate implementation cost of TRICOT approach to support scaling up and scaling out of the TRICOT methodology. Thank you for listening.